right, take your books out if you would, please. Open to page 188, and we'll get started by looking at the homework that you did over the weekend. Page 188, review numbers 3 through 12, practicing with adding, subtracting polynomials, then multiplying monomials. Important to remember that when you add polynomials together, you can only combine terms that are like to each other, or similar to each other. By the way, what does that mean for terms to be like? Adam?
The terms to have like.
Can you give an example of a couple of like terms?
Like the same literal that was called coefficient?
Yeah, there we go. Same literal coefficients, right? So for instance, a 7xyz and a 2xyz have the same letter, same literal coefficient. They'd be like to each other. We said with subtraction, same thing's true, except we never really subtract. What do we do, Joshua? We add the inverse. And then we said for multiplying monomials, we have 3 steps to multiplying monomials class. Those 3 steps are sign, number, letters. And we said as far as the signs go, if you multiply a couple of negatives class, you get a positive. If you multiply a couple of positives, you get a positive. If you multiply a positive and negative, you get a negative. But if you multiply negative and positive, you get a negative, right? If there were happen to be a series of factors, we said that if you multiply an odd number of negatives, you get a negative. But if you multiply an odd number of positives, you get a positive. If you multiply, it doesn't really matter how many positives there are. If you multiply an even number of negatives, you get a positive. We said that when you multiply like bases, class, add the exponents. But if you raise a power to a power, multiply the exponents. Let's try that again. So when you raise a power to a power, class, multiply the exponents. But when you raise power to a power, multiply the exponents. When you multiply like bases, add the exponents. Good. And if we said if we had a positive to an even power, positive. If we had a negative to an even power, positive. Negative to an odd power, negative. And a positive to an odd power, positive. See, we got this. We got this. There's no confusion here. All right. A negative power just means reciprocal. We're going to talk about that later. That's a coming. Don't get ahead of me. All right, number 3. We were adding these terms together, adding these polynomials. What did you get for your answer on number 3, Dylan?
Negative 2x squared, negative 2x, negative 23.
Careful, I've got a negative 2x squared and a positive 4x squared. I should keep the sign of the greater when I subtract. And so we should have a positive 2x squared, negative 2x, negative 23. Number 4, what did you get, Adam?
9x squared, negative 2x, negative 2.
Good, 9x squared, negative 2x, negative 2. Number 5, Joshua.
Negative x, negative 14.
Ooh, Dylan?
Negative 7.
Negative x, negative 7. Should have been our answer there. Okay, because on that last one we're adding the inverse, so we're going to put a negative 6 instead of a positive 6 there. So positive 7, negative 8, and then negative 6 when we add the inverse gives us negative x, negative 7. Number 6, back to Joshua for redemption.
Negative n squared, positive 4, and negative 10.
Close, and I'm wondering if maybe you just misread your answer, Adam.
Negative n squared, negative 8n, negative 10.
That is also not correct. Dylan.
Negative n squared, positive 14, and negative 10.
Should have been a positive 14n. So negative n squared to positive 14n, negative 10. You said positive 4n. So that's why I wondered if you just misread your answer. I was wondering if you had the 14 and just read a 4. All right, it's okay. Third tries the charm. Number 7, Joshua.
2x to the 5th, negative 5x to the 4th, negative 8x squared, positive 2.
And I like that he put them in descending order. Great job. 2x to the 5th, negative 5x to the 4th, negative 8x squared, positive 2 is correct. Number 8, let's go back to Adam.
Negative 5x squared, positive 2x, positive 15.
Great job. And again, descending order. I like that. Good. Negative 5x squared, positive 2x, positive 15. Number 9, when we multiply those monomials together, Lana.
X to the 10th.
Careful, when you multiply like bases, you add the exponents. So corrected answer. We'll rewind.
X to the
All right, number 9, Lana.
X to the 7th.
X to the 7th. Good. Number 10, Lana.
Negative x to the sixth.
Negative x to the sixth. Good. Number 11. Lana.
Why wouldn't it be 2x?
Well, 1 times 1 is 1.
Right.
Good question there. Yeah, the coefficients, the understood numerical coefficients are 1. And so negative times positive is negative. 1 times 1 is 1. X to the 4th times x squared, add the exponents, x to the 6th. Number 11, Lana.
Negative 48 x to the 5th y cubed.
Correct. Negative 48 x to the 5th y cubed. And number 12, Lana.
Negative 42 x cubed y squared.
Perfect. Negative 42 x cubed y squared. Questions on the homework. Do we need to see any of them worked out? There are a few of them we had issues with. Any of them we need to see worked? Is that a hand question?
Well, what's the answer is number 8.
Number 8 again was negative 5x squared, positive 2x, positive 15. Do we need to see that one worked out?
No, I said negative 15.
And do you see why you had a negative 15 and should have had a positive 15?
Yeah.
All right, questions. Flip back to page 91 then. Back to page 91. Obviously, if you're watching on YouTube and have questions, certainly email those questions to me and I will address them. All right, page 91, word problem 55, and let's go to Joshua. Go ahead and read this for us if you would, sir.
The difference between two numbers is 15. If 8 is added to twice the greater number, the result is 4 less than 3 times the lesser number. Find the two numbers.
All right, how many unknowns do we have, Joshua?
2.
2. And it refers to these numbers. One of them it calls a greater number. That's a terrible R. And so is the other one. And the other it calls a lesser number. That R is slightly better. Okay, so a greater number and a lesser number. And how does it compare the two numbers to each other?
The difference between them
Is
15.
all right, so let's suppose this. Let's suppose the difference between our ages was 15. It's more than that, but let's just say it's 15 so I can feel young, okay? If we knew that you all were 14, let's just say that's the number, then how old would I be?
29.
29, because if the difference between our ages is 15, I ought to be young again. If the difference between our ages is 15, then if you knew the smaller number, you just add 15 to get the bigger one, right? But let's suppose I was an old man, and I was like 37, and the difference between our ages was 15. Y'all would be old. How old would you be?
12. No, 20.
22, right? If you knew the bigger number, you would simply
Subtract.
subtract 15. Whichever way you wanted to go here. So which unknown gets to be x? Whichever one you want, Joshua.
The lesser.
The lesser, then how would I show the greater if the difference between them is 15?
X minus 15.
Well, that would make it greater though, would it?
X plus.
X plus 15. Now the other option, Joshua, is you could say the greater is x and the lesser is x minus 15. So you could use those unknowns, right? It's just depending on whichever one you wanted to call x. How many of you realized
I did that.
did one of those? All right, does it make sense now?
Yeah.
All right, so none of us actually figured it out last night or over the weekend, but it makes sense now. All right, so Joshua, let's go back to you. What does the rest of the word problem say?
If 8 is added to twice the greater number, the result is 4 less than 3 times the lesser.
You know, normally in a word problem, I tell you, find the one number you haven't used yet. Do you realize here, there's a whole bunch of numbers we haven't used yet. And do you see that that whole second sentence is basically algebraic representation? So this is a rare problem. We won't see a lot like this where really the whole problem's algebraic representation. So let's represent this together here, class. It says if 8 is added to twice the greater number. Now first we need to establish, are we going with the first column or the second column? Because either one works. All right, so Joshua says, let's go with the second line up here. Let's call the greater x and the smaller x minus 15. This is actually more intuitive anyway because it uses the term difference. Normally when you see difference, you think of subtraction. So this is the more intuitive way to set it up, is a bigger number is x and smaller would be 15, smaller with a difference of 15, though this would technically work. So if it says that 8 is added to twice the greater number, anyone, how would I write that?
2x plus 8?
There we go. 2x plus 8. If 8 is added to twice the greater number. And then it says the result is. What should I write next, class?
15.
No, the result is
Equals.
equals. And then it says for less than 3 times the lesser number. Someone besides Adam. For less than 3 times the lesser number.
3x negative 4.
Well, but the lesser number is an x. So 4 less than does mean we're going to subtract 4 from something, and 3 times the lesser does mean I'm going to multiply 3 times the lesser. But the lesser is an x class. The lesser is
3 times the quantity of x negative 15.
Does that make sense now? Now, the other way you could have written it is, if 8 is added to twice the greater number, the result is 4 less than 3 times the lesser number. That would have worked. Or, if 8 is added to twice the greater number, the result is 4 less than 3 times the lesser number. Does that make sense? At your seats, let's do this. Let's have Josh and Lana solve this one. And let's have Adam and Dylan solve this one. We'll get the same answers either way. So at your seats, solve the equation assigned to you, and then Scott, I want you to solve both of them.
Wow.
Because you can pause the video and give yourself more time if you need it. And just because I said that, he's not going to pause the video. He's going to try to finish both before y'all finish. So work fast. So
For
he
the
doesn't one up
problem,
you.
did
Because
he
otherwise
have-
he'll send me an email bragging.
For
I would
the
too.
problem, do you have to do both?
Mm-mm. No. Or this is just on a quiz test. You pick whichever one you want. I'm just showing both ways because they both work.
I'm supposed to do that one.
Right. You just solved the one that I assigned to you. All right, so if you were solving the first equation, you'd have gotten x equals 42, where x class represents the lesser number. So for your greater number, you would need to add 15 to get 57. However, if you solve the second equation, you'd have gotten x is 57. Well, that's because 57 is your greater number. And then to solve for the lesser, you'd have had to subtract 15 to get 42. Now, you get a different x depending on which way you solve it, right? But the actual answers of 57 and 42, you get regardless of the way in which you solve it. Questions on that? Does it make sense now if it didn't make sense before? Questions on that? All right, got a couple more word problems for you. And let's go and take a look at the screen here. And let's see here. Let's have Lana go and read the scores.
A basketball team won 16 games, or 4 less than 2/3 of the games that they played. Find the number of games they played.
All right, how many unknowns do we have here, Lana?
2.
What are they?
Won and lost.
No.
I mean, won and played.
The games they won, so we'll say wins, and games played. It never talks about losses. As an Indianapolis Colts fan, I prefer to do the same thing, which means I don't talk about very many games. But we prefer not to mention losses. Losses are never mentioned in the problem here at all. All it talks about is wins and the fact that they played games. Which of these gets to be X? The wins or the games played? Lana?
Played.
The games played, because it says that the wins were 4 less than 2/3 of the games that they played. So we'll let games played be X. How would I represent the wins, Lana?
X plus 16.
It doesn't say they won 16 more games than they played. It says
Hmm.
Hmm.
2/3 minus 4.
Close, really close. Dylan?
4 wins.
How would it represent the wins?
2x over 3 minus 4.
There we go. They won 4 less than 2/3 of, which means multiply the games that they played. And Lana, you said that games that they played is x. So 2/3 of, or times the games that they played, would be 2/3 x, or 2x over 3. But they won 4 less than that. So 2x over 3 minus 4. Does that make sense now? All right, how many questions, how many for thinking what Dylan said? All right, questions on this. Now there is one number we haven't used yet, which is usually how we approach these word problems. And what is that one number that is as yet unused, Lana?
The games played.
Well, no, we represented
Well,
games played as x. What number have we not used yet?
16.
16. And is the 16 the number of games they played, the number of games they won? Is it the number of losses? What is the 16?
1.
It's just the number of wins. So 16, class, is the number of wins. 2/3 x minus 4, 2x over 3 minus 4 is the number of wins. And here we have one unknown represented 2 different ways. How should I write my equation, Lana? We have forgotten from last week. Adam? If we have one unknown represented 2 different ways, the equation will always be, those who remember,
Equals.
the 2 ways equal to each other. So what should the equation be here, Joshua?
2x over 3 minus 4 equals 16.
There we go. 2x over 3 minus 4 equals 16. You just set the 2 ways equal to each other. Now at this point, I've got this fraction. I could clear the equation of fractions, but I showed you something last lesson that could save us a little bit of time. Instead of multiplying everything by 3 and getting some big numbers, if I got rid of the 4 by putting class a positive 4 on both sides, then all I would have is the fraction with the x equal to 20, and I can get rid of the fraction in one step and get x by itself, multiply by the reciprocal as opposed to everything by the LCD, right? The reciprocal being class 3 halves, 3/2, right? And if I put the 20 over 1, it'll make my life a little easier to see. We can cancel to get
30.
10, which gives us 30, which means that there were 30 games played. Now, we could deduce the losses if we feel we must focus on the negative. 14 losses. They didn't do great. 16 wins, 14 losses. And at least they won more than they lost. Okay, that's, for some teams, that's the objective. Just win more than you lose. Other teams, they want championships. Spoiled Alabama fans. Yeah, ultimately, as long as you win more than you lose, fans are having fun more often than they're angry. So that's always good. But 30 games played answers the question here. Questions on this word problem. Let's take a look at another one together. And read this one for us, if you would, Adam.
The original Pennsylvania Railroad station in New York was 780 feet long. This is 404 1/3 feet more than the length of the Capitol building in Washington, D.C. Find the length of the Capitol.
As you look at the word capital, ain't it supposed to be AL?
Yeah.
Actually, there's 2 spellings of capital, AL and OL. Do you know the difference?
AL was the city, and then OL was like
Hey, very good. I think in the 12 years of teaching, you're the first 9th grader to know that answer. Yeah. Capital spelled with an AL refers to a city. Like, for instance, Atlanta is the capital city of Georgia, or where I grew up, Tallahassee is the capital city of Florida, Washington, D.C., the capital city of the United States of America. But the Capitol building in Atlanta, where the legislature meets, or the Capitol building where Congress meets in D.C. So Capitol is the building, Capitol is the city. And if you ever were to look at an aerial view, the Capitol building, very long. There's actually underground passages as well. It's pretty intense. But anyway, it's very long, and so is this railroad station. Because train pulls in and lots of. Anyway, so we're comparing the lengths of these 2 places. So what are the 2 unknowns here, Adam? What are the two things being compared, shall we say?
The Capitol building and the Pennsylvania Railroad.
The Capitol building and the Pennsylvania Railroad station. All right, and which of them gets to be X, Adam?
The Capitol building?
Capitol building, so that's what it comes back to in the end. How would I represent the length of the Pennsylvania Railroad station?
404 1/3 plus X.
Or if we flip it because of the word then, we could say X, the length of the Capitol, plus 404 1/3. But you wouldn't have been wrong if you'd said your first answer. How else could I represent the length of the Pennsylvania Railroad station? You started to say,
780 feet.
yeah, it's also 780 feet, right? That's also a true fact, right? That's not so much representing, that's just stating the length. But this is also the length of the Pennsylvania Railroad station. So what equation should we use here? Back to Lana.
X plus 404 1/3 equals 780.
There we go. And here, it's kind of obnoxious having a mixed number. We don't usually deal in mixed numbers, but what do I have to do to solve for X here? Anyone?
You have to change it to an improper fraction.
Normally I would, but I don't actually have to do that here. I just, to get X by itself,
Subtract
just subtract the 404 1/3. Now, when we do, there is going to be a little bit of borrowing involved, right? I'm going to have to borrow 1 from the 780 to make it 779, and take the 1 that I borrow and write it as a fraction, 3/3, and then I can do my subtraction.
275 2/3.
And we do get 275 2/3 as X. So apparently the length of the United States Capitol building is
275 2/3 feet.
There we go. And the fact checker in me really wants to see if this is actually true. I may fact check this when y'all are working on your next assignment and see if this is a true problem. I found this one, so I don't know. This wasn't my personal research, so I'm going to put that disclaimer on it just in case these are lies, all lies. But I am curious if this is true. This is really random numbers for them not to be true, right? So surely it's true. All right, questions on this? All right, we'll keep working on more word problems as we move forward. Next section of notes, multiplying a polynomial by a monomial. Multiplying a polynomial by a monomial. We were practicing monomial multiplication for the last couple of lessons where we knew we had 3 steps to multiply monomials, class. Sign, number, letter. For multiplying a polynomial by a monomial, the steps are going to be pretty much the same. It's just going to be a little bit more of a process. And I want to kind of take you back before we get started with the algebra. I want to take you back to your elementary days. Okay, so I want you to flash back to when you were in, oh goodness, probably 3rd grade. I think Miss Bird teaches this.
No.
And if you were to multiply 413 times 2. Okay, this doesn't need to go in your notes. Good, it's 826. But the way your teacher would have taught you is this. She would have said you multiply 2 times 3, first of all. Class? 6. And then you'd multiply the 2 times the 1.
2.
And then you multiply 2 times 4. 8. And you get 826, right? Well, what's interesting is in arithmetic, everything we did went this way, right? We always start with the units digit. Then we went to the tens digit, then the hundreds digit, because we may have to carry some stuff, right? From one place value to the next. But you notice there was no carrying here, was there? So it wouldn't have been wrong for us to multiply this direction. Because there was no carrying, we could have gotten off folks saying 2 times 4,
8,
and 2 times 1,
2.
and 2 times 3.
6.
And we get the same answer, don't we? Because there's no carrying. Well, in algebra, you don't have to deal with carrying often at all. And because that's true, everything in algebra is going to go this direction. Why? Because that's how we intuitively think. If I were to write the word Joshua, you wouldn't say, Nobody reads this way. We read that way, right? It's how everything we do in life goes this direction, right? If there were a string of sentences, like, is
A bomb.
A bomb.
Oh.
For shame. Is let's just say Joshua is smart since he had perfect tests last year.
Yeah.
Just saying. Well, we wouldn't say smart is Joshua or trams see how is George. We read this direction, right? Everything we do in life. So why not then allow algebra to work intuitively and go this direction? For instance, maybe instead of a 400, maybe it's a 4x. Maybe instead of a 110, maybe this is a 1y. Maybe instead of 3 units, this is let's go with a negative here, mix it up, a negative 3z. And I wanted to multiply by 2.
Oh.
I'm going to multiply this direction. 2 times 4x, 8x. 2 times 1y,
2.
and 2 times negative 3z.
That's 6z.
I can multiply just that way. Does that make sense? Okay. Write this example in your notes if you would. Let's get a little bit more algebra-y by mixing in a few more letters here, since that's what we want to do in algebra. Let's multiply a 7ab negative 3b squared by a negative 4a cubed b squared. Well, we're going to multiply sign number letter once here, just as we multiplied the 2 by the 3, then the 2 by the 1, then the 2 by the 4, or 2 by 4, then 2 by 1, then 2 by 3. Well, so we multiply 2 times the 4x, 2 times the 1y, 2 times the negative 3z. So we're going to multiply a negative 4a cubed b squared by a 7ab. Then we're going to multiply negative 4a cubed b squared by negative 3b squared. But we're going this direction. So here, sign,
Negative
number,
20.
and with our letters, let's start with A
A to the 4.
and B.
B cubed.
And then we're going to multiply right here. Sign, number, letter. Sign,
Positive.
number,
12.
12.
A,
Cube.
just cube. We have no friends, but it's still an A cube. B
To the 4th.
to the 4th. And we get our answer that way. Does that make sense? Just like we would multiply by one digit after another. So we're going to multiply by one term after another, but we're going to go from left to right. At your seats, I want you to multiply this one. We'll start with an easy one. X plus 2 times 4. X plus 2 times 4. And Adam has it done in his head. So does, well, Dylan, I think, wrote it on paper.
I wrote on
Yeah,
paper too.
Oh, you're just that fast. All right, Adam.
4x plus 8.
4x plus 8. See, not intended to be hard. I assume we all got 4x plus 8. Even Dylan? All right, good, good. I'm thinking I'm Dylan. All right, how about this one? ax squared plus y times ax. Ax squared plus y times ax. Multiply by the one term, then multiply by the next term. Erase that Joshua is smart thing. And Joshua, what did you get?
Ax cubed positive ax y.
Close.
It was 2ax cubed.
Not 2, no, because 1 times 1 is 1. But a times a,
Oh, a squared.
a squared, and then x times x squared is x cubed. So we'll modify the answer slightly. 1a squared x cubed plus, if you wanted to say 1axy, you could. I'm going to add that answer with or without the written 1. All right, how about this one? 5m squared s plus 2t times 3st.
You couldn't write the 3st over on the right?
Everything we do goes left to right, so that's why I'm lining it up on the left edge, because everything works that way in algebra.
It's kind of weird.
Well, I'm reshaping your thought process here a little bit.
It's a bit brainwashing. It's like brainwashing.
Brain training. Brain training. Not brainwashing. Brainwashing would be, you are all Colts fans. You are all Colts fans.
Oh,
you are all Colts fans. So Lana, what do you get when you multiply?
15m squared s squared t positive 6st squared.
There we go. How many got the same answer Lana had?
Well, I got 6t squared s.
Well, see, Lana was doing it in alphabetical order, which is what I prefer. So we want to keep the alphabet intact. So, but not wrong entirely, just like minus a point for not staying alphabetical.
That's
How about this
really
one?
True. Like you could appoint things.
Oh, of course. Let all things be done decently and in order. Absolutely. We serve a God of order, so we want to be orderly in our mathematics. All right, so here's one for you. Let's go big. Let's take a 4x cubed plus 6x squared plus 2x plus 1 and multiply all that by a negative 3x squared. By the way, notice the descending order. Speaking decently and in order. All right, Dylan, what did you get?
Negative 12x to the fifth positive, no, negative 8 to the x to the fourth, negative 16x squared.
16.
Negative 6x cubed, negative 3x squared.
And that is the correct answer. Negative 12x to the fifth, negative 18x to the fourth, negative 6x cubed, negative 3x squared. How many had that same answer?
I did, I just drove.
Questions on that? Now, there is another way that we could write these problems. Instead of setting it up one above the other, mathematicians are lazy, and that takes far too much work. So what mathematicians may do is put the first value in front of parentheses, and then have the polynomial inside the parentheses. And when you see it written this way, you realize all we're really doing here is,
Multiply.
well, right, we're still multiplying, because something in parentheses, but this is essentially going to be distribution, isn't it?
Correct.
So if you would, in your notes, next to where you wrote multiplying a polynomial by a monomial, write the word distribution. That's really all we're doing. And we're multiplying sign, number, letter once, sign, number, letter twice. But the process really doesn't change. It's just easier for the math teacher to type the problem on the test if it's typed this way than if it's typed that way, because that takes up twice as many lines, and the lining stuff is annoying. Though at least you get to line it up along the left. So here we're going to distribute sign, positive, number,
15.
letters. Take alphabetical order. Start with the M,
And
Square.
then the S,
S squared.
and then the T.
T.
And then we do sign, number, letter again. Sign,
Positive.
number,
6.
letters. Let's start alphabetically. Let's start with the S,
S.
and then the T's.
T
Squared.
See there? That's all. Same answer as we got a moment ago. It's just a different way of writing the problem. So here, for instance, if I wanted to multiply that negative 3x squared, I could have put it out in front. And I would have distributed sign, number, letter once, twice, thrice, whatever 4 times is. All right? Or thrice, I don't know. Anyway, but we could distribute that way. Sign, number, letter. Class, sign,
negative
number,
12
letter.
x to the fifth.
And then we go to the next one. Sign,
Negative
number,
18.
letter.
X to 4.
And then sign,
negative
number,
6
letter.
x cubed
And then sign,
negative
number,
3
letter.
x squared.
And there we go. Same answer we got a moment ago, but it's written horizontally. It's written side by side. Write this down on your paper if you would, please. 3x squared times x squared, positive 4x, negative 5. 3x squared times x squared, positive 4x, negative 5. Let's go through sign, number, letter here. And how many times are we going to have to do sign, number, letter, Adam?
3 times?
Thrice, verily. Because there are 3 terms in that polynomial, that trinomial there. So let's take the first sign, number, letter, Adam.
The first sign number, positive, 3x to the fourth.
Good. Take the next sign, number, letter, Dylan.
Positive 12x to the x cubed.
There we go. And the last sign, number, letter, Joshua.
Negative 15x squared.
There we go. Just sign, number, letter over and over again. How about this one? Negative 4xy cubed times 5x squared y minus 3xy, positive 7x, negative 2.
That's what I'm saying.
There we go. Dylan's like, I'm tired of being bored with these easy ones. Give me something challenging. And Lana agrees. So Lana, take the first sign, number, letter.
negative 20 x cubed y to the fourth.
And how many sign number letters are we going to have to do here?
4.
4, because there are 4 terms in the polynomial. What about the second sign number letter? Lana?
Positive 12 x squared y to the fourth.
How about the next sign number letter, Lana?
Negative 28 x squared y cubed. And
How about the last sign number letter? Lana?
positive 8 x y cubed.
Perfect. See, even problems that look really ghastly, Lana handles with ease because she's so smart. If the rest of you were as smart as Lana, you too can handle them with ease. Scott, stop laughing. All right.
Yes,
It's not
Scott.
kind. Be nice to your niece. All right, so half niece. Sorry. All right, questions on this? All right. Page 187 in your textbooks. Page 187. I want you to do numbers 5, 6, 7, 10, 12, 13, and 14. So 7 problems. 7, the number of perfection.
5, 6, 7, 10, 12.
All right, quietly working on these 7 problems. Cut off the cube on the camera a minute ago. That 8xy cubed. I don't think the cube made it on the camera.
I'm gonna be leaving at 2:20 today.
That has nothing to do with the class. We're on video right now. That was all lies on that word problem. I'm going to have to change that word problem. The United States Capitol building is 751 feet, 751 and 1/3 feet. 751 and 1/3 feet.
They were kind of close.
Well, no, that was because the answer I think was like 251 and 2/3. It was way off. So
I was thinking.
yeah, I may have, when I copied the problem, I may have copied it wrong. That's a possibility that I just copied something incorrectly.
Where'd you get the 1/3 from?
And 1/3, that's 4 inches. So the 1/3 actually sounds right.
It's not hard.
Unless they just.
I probably copied the problem down wrong. Surely that's all. Let's see, now I want to find out how long the Pennsylvania Railroad station is.
You're that interested in the problem?
I guess.
I don't like to propagate fake news.
There you go. That's good.
Apparently the Pennsylvania Railroad Station in New York was one of the great architectural works of New York City. And when people stopped riding on train cars, they destroyed a whole bunch of the station to make room for other stuff. And then all, the historical preservation people, they're like, don't tear down that house, it's historic. You have to renovate it, you can't tear it down, kind of stuff like that. Those people got involved and were like, okay, no more blowing stuff up.
They were blowing it up.
Well, they had to blow it up so we make room to put other stuff there. So, I mean, this station was enormous. Apparently, took up gobs of space. Took up 2 whole city blocks.
Oh.
Like, think of all the other buildings we could put there. So, but I'm not finding how long it was. I'm finding all kinds of other cool stuff. Apparently, it was pretty fancy looking. There's the floor plan, but I don't see the dimensions. They don't show dimensions on the floor plan. Dang it. Oh well. You lose some, you lose some. In this case, the Pennsylvania Railroad Station is lost.
Why not? Yeah. You could try looking it up and then later.
It's okay, I'll come up with a new word problem so I don't keep propagating fake news.
It's just like
Wait, you
random.
made that problem?
Well, no. Like I stole it from somewhere, but I think either the problem, the place I got it from had their facts wrong, or I miscopied it, which is what I think probably happened.
Talk a little bit about
Stole
I did. I did. I'm too lazy to come up with my own original stuff. Want to feed down? All right, so let's see how we did here on these problems. Page 187, number 5. What was your answer, Dylan?
14a cubed negative 16a squared.
Good. 14a cubed negative 16a squared. Number 6. What did you get, Joshua?
72x cubed negative 36x squared.
Good. 72x cubed negative 36x squared. Number 7. Adam.
8x to the 4th negative 32x cubed positive 4x squared.
And perfectly read. 8x to the 4th negative 32x cubed positive 4x squared. Number 10. Lana.
15x to the 4th y squared negative 24x squared y to the 4th.
Ooh,
I
really
don't know.
close.
Maybe I'm reading
Dylan?
wrong.
15x to the 4th y squared negative 24x squared y cubed.
Just that last thing, y cubed, because we have a y squared and a y to the first for a y cubed. So
Squared?
15x to the 4th y squared negative 24x squared y cubed.
What? How is it x squared?
In the last term, look at number 10 in your book. You have a 3x squared y squared.
Where did I get the positive result?
Oh,
I think I did stuff on
you
the
mushed
other-
number 8 and number 10 together somehow. All right, for redemption, number 12, Joshua.
Negative 24a cubed bc negative 4a squared b squared c positive 18abc.
Good, negative 24a cubed bc, negative 4a squared b squared c, positive 18 abc. All right, number 13, what did you get for your answer, Dylan?
8x cubed negative 64x squared positive 8x.
Good, 8x cubed negative 64x squared, positive 8x. And number 14, Adam.
4x to the 4th y positive 3x cubed y squared negative 9x cubed y plus 7x squared.
Great job. 4x to the 4th y, positive 3x cubed y squared, negative 9x cubed y, positive 7x squared. Good. There were 7 problems there. Anyone 7 for 7?
No.
Okay, got 6 for 7. Just missed 1.
I just got a
5 for 7.
2 copier.
Okay. All right, so careful on your copy there. Any questions on this? Questions on this? Why don't you look at example 6.4d, the last example right above the practice section there. Notice there's a fraction being distributed. Oh, we hate fractions. I'm going to show you a shortcut, or not even necessarily a shortcut here, but what I'm going to choose to do is I'm going to write the 3x squared over 4, and then inside the parentheses, 8x over 1 plus 16 over 1. Okay, the advantage of making the fractions a little bit more all one fraction, looking up here now, Lana, making this all one fraction and making these fractions is you'll see that the canceling here, the 4 and 8 can cancel to give me class A 2 and a 1 technically. Now realize that's this multiplication. But when I go to the next multiplication, I'm going to be able to cancel again. Because this 4 is there again for the next multiplication. The 4 and 16 now cancel to give me a 1 and 4. And so now in both cases, we've canceled the 4 away. Now the distribution becomes class 6x cubed. You're right, there's an x right there, and that's it. And then here we get
12x cubed.
positive 12x squared. And again, just a little easier maybe if you show that step of making the fractions, putting over 1. Questions, comments on that? All right, just a thought. All right, your homework for this evening is to do page 187, the blue problems. Page 187, the blue problems. There's only 6 of them, so rather short assignment on that end. And then back on page 91, not 191, just 91, word problems 52 and 54. Page 91, word problems 52 and 54. And lesson 43, it's Monday, a week from today, you'll be taking your exam for this first quarter. So lesson 43 for Scott, for you guys, Monday will be your exam. It's the same thing, it's just, he thinks in terms of lesson numbers, not days of the week, because he's off. Yes, sir.
What was the first part of it?
Page 187, the blue. And page 91, word problems 52 and 54. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.